Number 78. From the data in Table 5.2, determine which of the following fuels produces the greatest amount of heat per gram when burned under standard conditions. And then they gave us these three options. So we have carbon monoxide gas, we have methane gas, which is CH4, and then we have ethylene, which is C2H2. And we want to know basically which one produces the greatest amount of heat per gram. Now, when they're asking for per gram, right, how many grams are we talking about? How many grams are we allowed to have for each substance? Yeah, when they say per gram, they're just talking about 1 g. So that's what I have to start off with for each one of these, right? So I have 1 gram of CO, I have 1 gram per the methane, CH4, and I have 1 gram of the ethylene, C2H2. Actually, it's not is it ethylene? Or is it acetylene? It's acetylene. Yes, acetylene. Acetylene is C2H2. Okay, so I went to table 5.2, and I basically got the information that we needed. So it's just the kilojoule amounts. So in that table 5.2, it tells us that for every 1 mole of carbon monoxide, I will release 283.0 kilojoules. For every 1 mole of methane, I will produce out 890.8 kilojoules. And for every 1 mole of C2H2, I will produce out 1,301.1 kilojoules. So we're going to use this information to just solve for how much heat, aka in kilojoules, 1 gram will produce of each. But now if I want to use this conversion factor, I can only use it in terms of moles and kilojoules. But for each one of them, I have grams. So what's the first thing, guys? I need to have either a mole or a kilojoule value. But I'm starting off with grams. But I can go from a gram to a mole. We've done this time and time and time and time again, right? All we're going to do is we're just going to multiply by a ratio, right? For each one of them. I don't want grams anymore. I'm going to throw the grams at the bottom. So grams of CO go on the bottom for the carbon monoxide. Grams of the CH4 goes on the bottom. And grams of the C2H2 goes on the bottom. I want to go to moles. So mole of CO on the top. Mole of CH4 on the top. Mole of C2H2 on the top. Let's just extend these lines. Beautiful. 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 Okay. Now remember, a mole to gram conversion of the same compound, that's what these all are. What are we using? Oh yeah, we're using the periodic table. And remember, when you use the periodic table, it's always 1 mole. So 1 mole of CO, 1 mole of CH4, 1 mole of C2H2, all equals the molar mass on the bottom, right? The mass on the periodic table goes with the ones on the bottom. So let's just count that up. Okay, so I'm going to start with CO. I just take literally 1 carbon and 1 oxygen. 12.01 plus 16, I get 28.01. Let's do methane. 12.01 plus 4 times 1.008. I get 16.042. And then let's do acetylene. 2 times 12.01 plus 2 times 1.008. 26.038. And now grams cancel out. Okay. Now let's incorporate this. Let's not stop because we're not at the answer yet. We want to see how much heat is being produced per the 1 gram. And yeah, that's good. I was going to say I didn't mean to cancel out the 1, but I didn't cancel out the 1. Anyway, so now I'm going to use this conversion factor. I don't want mole of CO anymore. I want to put that on the denominator. So times by a ratio, right? One last ratio, guys. And maybe I can move this over a little bit. and move this one over a little bit. Okay, so times by a ratio, times by a ratio. There we go. Mole of CO goes on the bottom. Mole of CH4 goes on the bottom. Mole of C2H4 goes on the bottom. C2H2. Now let's incorporate that kilojoule. Kilojoules goes up on the top. And we're just going to use those numbers, right? Because I have 1 mole of CO equals negative 283.0 kilojoules. So 1 mole of CO equals negative 283.0 kilojoules. These cancel out. 1 mole of CH4 equals negative 890.8. So negative 890.8 moles cancel out. 1 mole of C2H2 equals negative 1,301.1 kilojoules. Okay. And moles cancel out. And now we're left with the unit that we want. We want kilojoules. We want that heat. So we did it correctly. Now we just got to find out what's the answers. Maybe I'll do this in black. Okay. So let's see. I'm going to start with CO. All you're basically doing is you're taking the 283 divided by 28.01. So I get negative 10.10 kilojoules. Okay. And maybe this looks a little weird. The answer is just going to be whatever that was, right? Okay, so let's do it for CH4. 980.8 divided by 16.042. I get now a negative 55.53 kilojoules. Okay, and then 1301.1 divided by 26.038. I get roughly 40, and this is a negative value, 49.97 kilojoules. Okie dokie. All right, so now we just got to figure out which one wins, right? Which one produces the greatest amount of heat? Now remember, the negative does not mean that it's literally a negative amount of heat. The negative means that it's just being released into the surroundings, aka the environment. So the environment's going to get hot. So don't look at the negative. Look at the actual number. This is how much is being produced. So out of 10, basically 10 kilojoules, 55 kilojoules, and basically 50, right, 49.9 kilojoules, which one is the highest number? It's the methane. This one wins. Because you would release, that's just what the negative means, you would release 55.53 kilojoules into the environment. Then this guy comes second, the acetylene, C2H2, and then comes the carbon monoxide. Mainly because these are much higher than this one, even though this weighs more. This is not a hydrocarbon. Hydrocarbons are beautiful. You know, they're better when they're being combusted. So, can't produce any water from this. All right? Anyway, I hope this helps. So, just to recap, they just said determine which of the fuels produces the great amount of heat. It's the methane, because it's the highest number, not including the negative. All right? So thank you so much for viewing the video. I really hope this helped. Let me know in the comments. Subscribe to the channel. And thank you so much for that. Really do appreciate it. At the moment, we're almost at 15,000 subscribers. The channel's at 15,000 subscribers. It's absolutely crazy. So let's just keep going, all right? I'm really glad that my brother and I are providing such great help for you guys, you know, through your education, and that you guys think that this channel is a great educational resource when studying for math, physics, or chem. So I'm so grateful, and thank you, all right? I'll see you all in later lessons. Have an awesome day. Bye-bye.